In this video, you'll learn how to evaluate expressions with logs or logarithms in them. Becoming more comfortable working with logs is important because we will be using them to help us solve exponential equations in a future lesson. Before we evaluate, let's review rewriting log expressions with exponents. So here we have log base 3 of 177 equals x. We're going to rewrite that with exponents instead of logs. Now the base number stays the same. Remember we said log base 3. So the base number is 3. The log equals the exponent. So the x will be the exponent. And then that equals 177. So the base number for our log is the base number for our exponential expression. The log equals the exponent. And then we fill in with the other number. So the base is m. The exponent is v. And it equals 82. So we can go back and forth between exponential form and logarithm form. Okay, so now we're evaluating, and remember that the log equals the exponent. So we're wondering, 8 to what power equals 64? Well, we know that 8 squared equals 64. So log base 8 of 64 equals 2, because that's the exponent. Here we have a base of 2. We're wondering what exponent we need to use to end up getting 8. Well, 2 to the third power equals 8. So log base 2 of 8 equals 3, because that's the exponent. Okay, here are a couple of problems where we will probably need to use a calculator to help us. We're wondering 5 to what power equals 3,125. Well, you might not have your powers of 5 memorized, so let's open up a calculator and just give a few numbers a try. So let's try 5 raised to the 4th power. That equals 625, but we want to get 3,125. So let's try 5 raised to the 5th power. And there we have it. 5 to the 5th power equals 3,125. Now, since the exponent is 5, that means that log base 5 of 3,125 equals 5. Remember, the log equals the exponent. So this 5 here is this 5 right there. Now we're wondering 3 to what power equals 729. Let's try 3 raised to the 7th power. That's too big, 2,187. We just want 729. So let's try 3 to the 6th power. There it is. 3 to the 6th power equals 729. So log base 3 of 729 equals 6. The log equals the exponent. Okay, here we have some fractions. So we have 3 to some power equals 1 over 243. So this one, we're going to need to use a negative exponent, because negative exponents have everything to do with fractions, not negative numbers. So first, let's just focus on 3 to what power equals 243. And then we'll talk about how to make it a fraction. Let's see, 3 to the 6th power is 729. And we want 243, so let's try 3 to the 5th power. There we go. All right, let's make a note of that 3 to the 5th power equals 243. But we want 1 over 243. Well, that would be 3 to the negative 5th power. Because a negative exponent just means that the 3 to the 5th power is in the wrong place. We need to move it down to the denominator. So log base 3 of 1 over 243 equals negative 5, because 3 to the negative fifth power equals 1 over 243. All right, so we have 3 to some power equals 1/9. Well, we know that 3 squared equals 9, but we don't want 9, we want 1/9. To get that 9 in the denominator, we need a negative exponent. So log base 3 of 1/9 equals negative 2, because 3 to the negative second power equals 1/9. Be on the lookout for special cases. Here we have 17 to some power equals 1. Well, anything to the 0 power equals 1. So log base 17 of 1 equals 0. And we have 23 to some power equals 23. Well, that'd be 23 to the first power equals 23. So log base 23 of 23 equals 1. I hope these examples about evaluating logs have been helpful. This is Mr. Ela, signing off.